Hey friends, today we're talking about similar figures and scale factor. Similar and congruent polygons. So let's talk about what the difference is between similar and congruent. Similar means same shape but not the same size. We use this symbol right here to show that a figure is similar. Okay, so these two down here are similar. They have the same shape. They're both right triangles with the exact same angles, but they don't have the same side lengths. Okay, so I added that to the definition. Please write that one down, pause the video and do that for me. Also write down congruent. Congruent means they have the exact same shape and same size. So when I say shape, I'm always meaning angles. When I say size, I'm always meaning the side lengths. Okay, so write those two down. These two are congruent. If you look, they have the same angles and all of their side lengths. These three tick marks mean that size is the same. This one means that one. This one means that one's the same. And these angle markings, if they have the same angle marking, then their angles are the same. So down here, take a look at how I write that. Angle A is the same as angle D, for example, and all the other ones are. Side length AB is written with a line, and side length DE is written with a line as well. So those two are the same. If we have figures that are similar, we can find missing side lengths because they should be proportionate. So just like when we were working with ratios, we can set up two ratios next to each other to form a proportion. So I'm looking for JK, which is the same as GF in terms of their position in the figures. So I'm going to do X, and I get to pick either of these that I want to. I'm going to work with this 40 right here. So X over 40 equals, and then who goes with the 40? The 48. So equals my 24 over 48. So what I have here are two similar figures, and their ratios of the numbers in each figure are in proportion. So I can use cross products to solve, I can simplify and then solve. It's totally up to you. So 48 times x is 48x, equaling 24 times 40, equaling 960. So I divide by 48, and I get my x equaling 20, and these are meters. You could also have simplified 24 over 48 to 1/2, and then you know that 1/2 of 40 is 20. Totally up to you how you solve it. Use your problem solving. But if you can't figure it out, you can always use cross products. Down here, they don't give us any options to use other than these. So I'm going to do x over 27 in this figure, starting with my x, and then x is paired with 35, so 35 goes on top. And 21 is paired with the 27, so it goes in the denominator in the bottom. So x times 21 is 21x, and that equals 35 times 27. So 945, and we divide by 21, and we get 45, and these are inches. Okay, so go ahead and find the unknown length in this one, and I'll be back in just a second to show you what I did. Okay, hopefully you paused the video. So I always start with my x and find out who he's paired with, and then my other two. So x over 6, because they're in the same figure, equaling my 50 goes on top because it's paired with the x, and my 15 is paired with my 6, so it goes on bottom. Okay, using my cross products, I get 300 on one side, 15x on the other, and when I divide, I get 20 meters. If the figures are congruent, it's much easier because we know all the side lengths that pair together are equal. So, for example, we know that RS right here corresponds with XY. So this length is also 6 inches. We know that RT, this slanty side, pairs with XZ, so this is 11 inches. And we know that YZ pairs with ST, so this is 8 inches. And these are how we write them, okay? corresponding angles would be angle R with angle X, angle S with angle Y, and angle T with angle Z. Notice that when I draw them for myself, I always set them apart differently. So if they asked us to find XY, we know that XY equals RS, so it's 6 inches. So let's look at this example. Triangle JKL is congruent to RST. Here's your hint. J then goes with R, K goes with S, and L goes with T. Their position when they name the triangle means that their angles are the same. So if S and T go together, then K and L go together. So if this is K and L, and this is S and T, then we know that S and T equals 5. Please write this in your notebook. We're talking about similarity and scale factor. If two polygons are similar, the ratio of their lengths of corresponding sides is called scale factor. Okay, write that down. We abbreviate scale factor SF. So if they give us two similar triangles, remember this symbol means similar, then we know that they are in proportion. How are they related? How big is one versus the other? That's where scale factor comes in. So we're trying to figure out what we're doing to this shape to get to this shape. So in this particular one, if this is my new figure, okay, and this is my original, I'm trying to figure out how I get from this one to this one. So I'm going to take one of the lengths of the sides, like 16 and 12, since they correspond, and I'm going to put the 16 over the 12 and simplify. So to get from here to here, I have to multiply by 4/3. Plug that in your calculator. 12 times 4/3, and you get 16. Notice that this works for every single side length. The scale factor should be the exact same. So the ratio of the lengths of the corresponding sides, or the scale factor, is 4/3 in this situation. If I swapped and I went from this one to this one, then the numbers would also swap. The way that we would look at that then would be, it would be a scale factor of 3/4. Why? Because this one's bigger and it's getting smaller. Your scale factor should match the sizes. So if it's less than 1, it's getting smaller. If it's bigger than 1, it's getting bigger in terms of its shape. Let's look at another example. Given that triangle ABC is similar to DEF, find the ratio of their side lengths. Okay, so let's look at 6 and 9. So I'm getting bigger or smaller? I'm getting bigger. So we take our new shape, and it's 9/6, or 3/2. If we look at another one, for example, the 10 and the 12, then I do 12/10, which simplifies to 6/5. Uh-oh, my scale factor is not the same. That's because I didn't pick the same shape. It's not or the same side that corresponds. It's not going to be a 12, it's going to be 15. So you have to be careful, guys. Your scale factor should always be the same based on the side lengths that you pick. If I did the 12 and the 8, it would be 12/8, or again, 3/2. So my scale factor from this shape to this one is 3/2. We can check for similarity because of that. So an art student is copying a painting. The copy is 48 inches long and 36 inches wide. The rectangular region that she's copying is 16 inches long and 12 inches wide. Are the original and the copy are similar figures? If we take the length of the original over the length of the copy and we set it equal to the width of the original over the width of the copy, if they equal one another, then they're similar. So notice that both of these equal 1/3, so they are similar. Why don't we try this one together? We've got a rectangular kitchen and a rectangular den. They are 9 feet by 12 feet. And the other one is 12 feet by 15 feet respectively. Do they have the same or similar shapes? So we do our 9 with this 12, and we don't know if they're equal, but we're going to check. And then we do this 12 with this 15. So let's see if they are similar. Does 3/4 equal 4/5? No, so these are not similar shapes. And that's all I have for you today. See you next time.